Hello everyone, welcome back to our pre-algebra review, and today we will be discussing simplifying square roots. So first off, what's a square root? Well, it is known that if we have the square root of 25, the answer to this will be a number when multiplied by itself, getting us back to 25. So if we take 5 here, we know that 5 times 5 equals 25. Since 5 is being multiplied by itself to give us what is inside the root, it is known that the square root of 25 equals 5. So, what if we have different operations in the square roots, like addition and subtraction? So, if we have, say, the square root of 6 plus 3, you might be tempted to do the square root of 6 plus the square root of 3. However, this is not allowed. When we have addition or subtraction inside the square root, we must first perform the operation. So we must do 6 plus 3 equals 9, the square root of 9, which is equal to 3. So if we take a subtraction example real quick, if we do 100 minus 19, again, we could not take the square root of 100 minus the square root of 19. We would first have to calculate the difference of 119 of 81, and then take the square root of 81 to get 9. Alright, but what if we have, instead of addition or subtraction, multiplication like this? Well, we actually can simplify this before performing the square root, and this is where we get into the product rule. So, if we take the square root of x times y, this is equivalent to the square root of x times the square root of y. So, as an example, let's take the square root of x squared y squared. Well, by the product rule, we can make this the square root of x squared times the square root of y squared. So, what's the square root of x squared equal to? Well, if you remember, we want an answer to when multiplied by itself is the number inside the radical. So if you remember from the previous video of multiplying exponents, if we take x1 times x1, this would equal x1 plus 1 equals x squared. So the square root of x squared equals x to the first. And the same would be true for y squared, as y1 times y1 equals y1 plus 1 equals y squared. The square root of y squared equals y1. So that means we would have the square root of x squared y squared equals the square root of x squared times the square root of y squared equals xy. Alright, now we've done examples with variables, but now we're going to get into examples with only numbers, and this is actually simplifying square roots. Okay, so we know simple square roots such as the square root of 9 equals 3, or the square root of 16 equals 4, or the square root of 25 equals 5. But what if we have something a bit irrational, such as the square root of 90? Remember, this is irrational because it is not because if we take this square root and put it into the calculator, it is not expressible as a fraction, and it cannot be is a decimal that does not end. So, what we're going to do here, in order to simplify this, is we must first list out the factors of 90. The factors of 90 will be any two numbers that will multiply to 90. And usually what I do to calculate this is I'll take 90 and I'll just divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in the calculator. And if those quotients produce a whole number, then I will list that as a factor. So, for example, if we take 90 divided by 1 equals 90, meaning that 90 and 1 are factors. 90 divided by 2 equals 45. 45 and 2 are factors. 90 divided by 3 equals 30, meaning 30 and 3 are factors. 90 divided by 5 equals 18, meaning 5 and 18 are factors. 90 divided by 6 equals 15, meaning 6 and 15 are factors. And 90 divided by 9 equals 10, meaning 9 and 10 are factors. Alright, so now that we have the factors of 90, what's the next step? Well, we know that we're going to be wanting to use the product rule since that's all that's been discussed so far. So we want to write the square root of 90 as the square root of two multiplication problems. So if we think, the square root of 90 times the square root of 1 would just be what we have initially, so that's not going to help. If we have the square root of 45 times the square root of 2, this is two irrational numbers, again, not helpful. Square root of 30 times the square root of 3, two irrational numbers. Square root of 15 times the square root of 18, two irrational numbers. Square root of 6, square root of 15, again, irrational. But when we get here, and we get the square root of 9 times the square root of 10, we have one rational number. So, since the square root of 9 is rational, and we have one rational number inside the square root, what we're going to want to do is express the square root of 90 as the square root of 9 times the square root of 10. And then we know that the square root of 9 is 3, and we can just bring the square root of 10 down. So this is square root of 90 simplified. So the steps to simplify square roots are, first, to list factors of term inside the square root. And then second, find a pair of factors where 1 is rational. 3, express the original problem as a multiplication of the two factors, and then we will repeat until there are no rational factors. Alright, so let's take another example. Let's take the square root of 45. So again, to list the factors, we will do 45 divided by 1 equals 45. So we have 1 and 45. 45 divided by 3 equals 15. So we have 3 and 15. Square root of 45 divided by 5 equals 9. So we have 5 and 9. Alright, if we list the factors as square roots of each other, the square root of 1 and the square root of 45 is irrelevant since that's equivalent to our initial problem. The square root of 3 and the square root of 15 are both irrational, so we do not want that. However, if we look at the 5 and the 9, the square root of 9 is rational, so we will want to use this. So what we will do now is express the square root of 45 as the square root of 5 times the square root of 9. The square root of 9 is 3. Bring down the square root of 5. And if we take the factors of 5, it is only 5 divided by 1 equals 5, 1 and 5. Since this is irrelevant as this is equivalent to 5, we now have our simplified square root. So now we're going to get into a few more complicated examples as we add in some variables into the problems. So if we look at another example, let's take square root of 32, a to the 9th, b to the 5th. Alright, so now take a moment to solve this problem yourself, please. Okay, now that everyone's had a moment to pause the video, let's go ahead and get into this. So we're going to want to treat 32, a to the 9th, and b to the 5th all separately. So let's go ahead and use the product rule. Alright, let's start with 32. First, list the factors of 32. So we have 32 and 1, 16 and 2, and 4 and 8. if we see here, the 4 and 8 all have a rational answer, and the 16 and 2 have a rational answer. So we could use either of them. In the end, the result would be the same. We would just have to do an extra step if we use one. So let's use the one where we have to use an extra step. Let's use the 4 and 8. So let's write square root of 32 equals the square root of 4 times the square root of 8 equals 2 root 8. We can write 8 as 8 divided by 1 equals 8, 8, 1. 8 divided by 2 equals 4, 2, 4. So the square root of 2 times the square root of 8 equals 2. Square root of 2 times square root of 4. Square root of 4 equals 2. So we have square root of 2 times 2 times 2, or 4 square root of 2. Okay? Now, let's get into the a to the 9th. So, remember, if we use the product rule for exponents, we can write a to the 9th as a to the 5th plus a to the 4th. A to the 5th times a to the 4th, since a to the 5th plus 4 equals a to the 9th. So the square root of a to the 9 can be expressed as the square root of a to the 5th times the square root of a to the 4th, meaning that this can be reduced as a2 times a2 equals a4. So we can have a squared a to the 5th equals square root of a to the 9th. So now let's finish off with b. If we have b to the 5th, we can write this as b to the 4 plus 1 equals b to the 5th. So what this means is b to the 4th times b equals b to the 5th. If we use the product rule for square roots, we have square root of b to the 5th equals square root of b to the 4th times the square root of b equals b squared root b. Now, if we bring all of this together and plug it back into the initial equation, of 32 root a9 root b to the 5th, we have the square root of 32 times the square root of a to the 9th times the square root of b to the 5th. Now what we're going to want to do is plug in all the simplified forms we received. So the square root of 32 equals 4 root 2. Square root of a to the 9th equals a squared root a to the 5th. Square root of b to the 5th equals b squared root b. And again, I missed this, but we can actually reduce a to the 5th again. So if you have a squared a to the 5th, root a to the 5th can be written as a to the 4th times a to the 4th. So if we write square root of a to the 5th equals root a4 times root a, we have a squared root a. So going back in and plugging all of these answers in, we can now finish simplifying the problem by multiplying everything outside the roots together and everything inside the roots together. So we will have 4 times a to the 4th times b squared, 2 times a times b, giving us 4a to the 4th b squared over ab. Alright, so we'll work on one more quick example today of multiplication. So let's take the square root of 72, x to the 10th, y to the 7th, z squared. So again, let's use the product rule to have each term on its own. Alright, if we start with 72, we can list the factors of 72 out. So we have 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, and 8 and 9. So if we see here, all of the ones circled have rational square roots. So if we use any three of these, we would end up getting the right answer as long as we continue to simplify. But I'm going to use the 2 times 36 equals 72, as this will leave us with the least to simplify. So we can write the square root of 72 as the square root of 2 times the square root of 36. Square root of 2 cannot be simplified anymore, and the square root of 36 is 6. So we have the square root of 72 equals 6 root 2. So we have the square root of x to the 10th, and we can write this as the square root of x to the 6th times the square root of x to the 4th, since x6 times x4 equals x6 plus 4 equals x10. So the square root of x to the 6th can remain as x to the 6th. The square root of x to the 4th can be x squared, as x2 times x2 equals x4. Now we can reduce x to the 6th again. We can make this x to the 4th times x2, because x4 plus 2 equals x6. Square root of x to the 6th equals square root of x to the 4th plus the square root of x squared, which equals x squared times x. So plugging this back into the original problem, we have x squared times x squared, or x to the 5th. So the square root of x to the 10th equals x to the 5th. We now move on to y to the 7th. We can write this as the square root of y to the 7th equals square root of y to the 4th times square root of y cubed. Square root of y to the 4th is y squared times the square root of y cubed. Square root of y cubed can be written as the square root of y squared times the square root of y, since y squared times y equals y cubed. Square root of y squared is y. The square root of y is always simplified. Plugging this back in right here, we get y squared times y square root of y, giving us y cubed root y. And then finally, we have the square root of z squared, which is just z, since z1 plus 1 equals z2. So if we write again the expanded form of the problem of square root of 72, square root of x to the 10th, times square root of y to the 7th, times square root of z squared, all we have to do now is plug in all of our simplified forms into this equation. So we have the square root of 72 equals 6 root 2. Square root of x to the 10th equals, I believe it was just x to the 5th. Square root of y to the 7th equals y cubed times y, the square root of y. And the square root of z squared is just z. So again, if we multiply everything on the outside together and then everything on the inside together, we can then have the final answer. So if we go outside root, we have 6 times x to the 5th times y cubed times z, giving us 6x to the 5th y cubed z. Inside root, we have 2 times y equals 2y. Putting this together, we get 6x to the 5th y cubed z square root of 2y. And this is the simplified form of the equation 72x to the 10th y 7th z squared. Alright, that's going to be all for today. Next time we will just continue simplifying square roots, and we will be talking about the quotient rule next time. Thanks.